we continue our discussion based on the convolution. We extend the concepts in two-dimensional convolution. Right. So in the previous session, the convolution we considered was a two-dimensional case, but yeah. So about the result, we need to highlight something. Okay. So let's consider the first problem we solved. Right here, what is the size of your x? X is actually of size. I think this is 4 into 4. The second function had a size 2 into 2. Okay. Now, so convolution of a 4 into 4 image with a 2 into 2 image. If you consider the output, that is y, it is a 3 into 3. You can see that, right? The x is your image, y is a filter you are applying on that image, and the size of the y reduces, right? So I can see that my input was 4 into 4. I convolve with the filter, right? Convolutional filter. So that actually reduced my size of x. Result is lesser in size, right? So I lose my information. So same thing you are going to observe here. We when you solve this homework problem, we had a 5 into 5 image, convolving that with a 3 into 3 filter. The result is lesser than 5 into 5. Okay, so this is what we are going to observe now. Anyway, so now what if you don't want that thing to happen? Okay, so what if I don't want, right? I want the same size to be retained. Let's consider the same example, right? And we'll solve a problem now. Okay, so if you don't want this, right? So to avoid the reduction in size, so there has to be a solution. What if I want the same 5 into 5 as answer, right? So in that case, you just have to avoid the reduction in the size of your particular what you call result. Then you have to perform what is called as a zero padding, right? So you have to pad so many number of zeros such a way that the convolution results in, right? You don't lose any points. Okay, so let's try to do this now. So I have this x. Anyway, let's copy this x. So this is the same problem we are trying to solve with the zero padding. Okay, right. So that means, okay, let me copy this. Let me copy this. Yeah, now we are going to implement the zero padding. Okay, so we'll solve, right, this problem with zero padding, so that result is 5 into 5. Results size will not reduce. Okay. So now, whatever x I have, I perform the zero padding, right? Only for the first function you have to do that. The second one, the h, you don't do. Okay, so let's write this. So zero padding. So x, I'll just write a notation z here, just to say that this is a zero padded, okay, of n, comma n is equal to. So now let me paste that. Okay, now you see I pad zeros, one row of zeros above, and one, I think one of the number has not been copied. I think that's also one. Let me just, yeah, it's minus one, one. So there is a minus one here. So you see, I actually padded one complete row of zeros. Okay, and I need to add a column as well, right? Top row, after bottom row, and one column to the left and one column to the right. This is a standard way. Whenever you use a 3 cross 3, whenever your h is 3 cross 3, Okay, you see, if H is 5 cross 5, let's assume H is much bigger, right? Then I might have to add 2 rows and 2 columns at the top, left, right, and bottom. You'll come to know, right, how to decide that. Okay, we'll do that as an exercise at a later stage. Okay, so now you see, right? I added 1 zeros. Why it is done 1 row to the left, 1 row to the top, sorry, 1 column to the left, 1 row to the top, and 1 column on the right side and 1 row below, because now my matrix is a 5 into 5, sorry, 3 into 3. The H is 3 into 3, correct? So which means assume the H coming here. Now, previous case, when you solve this problem without zero padding, what will happen? Right? You actually start from here, right? So your result is coming at this location, not at this location, right? Your result is at the center. Now, when you shift it to right, right, you get your result where you get a result here, and you don't get a result here because there is no overlapping. So you don't do this, correct? In the normal procedure, you don't do that. Right, like that. Next, you get one here, one here, one here, because yes, you can calculate. And in the next stage, you will calculate here, here, and here. You don't do this. So your actual result is a 3 cross 3 in that case. So 5 cross 5 got reduced into 3 cross 3. Right? When you don't perform what is called as the zero padding. That's the problem. I lose my information. Right? My answer is not proper, not the expected. So what you are going to do now, you will perform, right, the zero padding like this. Now let us see what happens. Now I'm not starting from here, right? This is not my starting point. My starting point is this. I start my convolution from here, isn't it? Sorry, I think something happened. Got erased. Let me just write that. I think one column. Now you see your convolution begins from this position. Okay, and that position is somewhere here, right? So top left, when you overlap that, where do you get your result comes here, which is the expected position. Next comes here, 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 as well as here, because this is my last position. I get an answer starting from there. Let's move to the last position. It's like this. I am getting the positions like this, and so which actually results in a 5 cross 5. Okay, you're right. Now let us solve that. Let's today's objective first is to perform a manual calculation, and then we want to write a code and verify that how to perform a 2D convolution using the matrix notation in MATLAB. Okay, right. We'll do check both of them first today. Okay, so let's do the convolution. Starting from here, let me write the H here. This is the normal H of m comma n, which is already given. Right, let me just copy from here. Okay, this is the H. Okay, right. Now start performing the convolution. My answer begins from y of 0 comma 0, or y of 1 comma 1. That's the easiest notation. All right, please do that. Y of 1 comma 1. How do you calculate? Right, overlap into this position, right? Overlap the edge over here. So leftmost and the topmost row, you are not multiplying because they are zeros. Only -1 into 1. Okay, let's write that. So how do you calculate that? This is -1 into 1, that is -1. Then you have plus 2 into -3 is -6. Then 2 into 2, that is equal to 4. Then 1 into 0 is a 0. So this is minus 7 plus 4. Should it be minus 3? All right. Okay. Like this, take your time and complete a 5 into 5 matrix. Okay. Once you have the answer, you let me know. I'll write. Okay. I'm directly writing the result now. So this is y of m comma n. All right. So this is equal to minus 3, starting from minus 3. Okay. So next entry. Right. So in order to find the first point over here, right, that is y of 1 comma 1, what we did, we simply brought this h of m comma n over this position, correct? So just see 1 into 0, 2 into 0, this into 0, 2 into 0, minus 1 into 1, 2 into minus 3, minus 1 into 0, 2 into 2, 1 into 0. This is what I did, correct? So point by point multiplication, it's actually a dot product, right? By placing the h or the smaller matrix over the larger matrix, right? Such that there is, right, overlap. Okay, now you got a point minus 3. So how do you calculate your next position? Bring the h to the next shifted position. Shift along x-axis, that is this, right? So 1 into 0, 2 into 0, 1 into 0, everything answer should be added. So 2 into 1, minus 1 into minus 3, 2 into 4, 2 into minus 1, 0 and 0. So add the result to get your second answer. That is h of 1 comma 2. Are you okay? So I hope you are understanding what to do, right? So what you will do next in order to find y of 1 comma 3, move this to the right by one more position. You have to move it to the right. In the sense, right now I am in the second position, right? You will move further. So your position will be like this, right? Next you do this, and then you do this and you stop. You cannot move further because there is nothing on this side. Once you do that, once you finish this, you might have 5 points with you, which is y of 1 comma 1, 1 comma 2, 1 comma 3, 1 comma 4, and 1 comma 5. Once you have that, in your next step, what you are supposed to do, move down by one bit, because one row is completed, move down. So start from here. Okay, so this is 2 comma 1. Answer y of 2 comma 1. You get a result. Then 2 comma 2, 2 comma 3, 2 comma 4, 2 comma 5. Like that you go till 5 comma 5. So total 25 points are expected in this answer. Okay, hope you are fine with this. Right? Yeah, please do that. Let me know once you're ready. Okay, so the results of this convolution. Okay, we'll write down the results. Okay, so I'll give a notation. This is y of m comma n equals to, I think the first value is already calculated, minus 3. Okay, then yes, 11 minus 17, 24. Sure, this is minus 21. Okay, this is minus 4, 6, All right, so that is 8, 3. Okay, y of 2 comma 5, y of 2 comma 5 is 15. All right, 10, 1, 11. Okay, 6, minus 3. Okay, then we move on to the 4 comma 1 position of y. Okay, y of 4 comma 1. 4 comma 1 is it 6? Okay, minus 1. All right. This is minus 1, then I think 6, right? Okay, 4 comma 3, 5. 4 comma 5, I heard that is 12. What's 4 comma 4? This is 10. Okay, let's move to the fifth row, 5 comma 1 position. So this is 6, minus 1, 12, minus 5 comma 4, minus 3. Okay, 4 and minus 3, right? Okay, so we have 4 and so far we were solving a problem in two-dimensional convolution. We got the answer, and we can observe that because of the zero padding, the size of the original function, that is x, is retained over here. Okay, now our intention is we have to write a program to perform what is called as the two-dimensional convolution. Okay, so let us jump to the MATLAB screen and let's get started with the coding. Okay, so in MATLAB, let's directly write the function. Write a function. So I'll create a function by the name conv to. Okay, so it's a two-dimensional convolution. Since this function does not exist, it opens up a window. Okay, so my intention is to write a function itself. Okay, so this is a function, say it results in a matrix, so I'll call the matrix as B. Okay, so result B is equal to, this is the same name as conv to dimension. You have to specify what you pass, right? I pass two functions. Okay, so let me call this as say y is equal to, one is x, and the second function will be h. Okay, now so first let me extract the, what you call, the dimensions. All right, let the dimensions be, first one is rows and columns is equal to, I just want to call the size function, size of the first one, that is x. Okay, similarly let me call the second one as m and n equal to the size of the second function, that is a, I think h. Yes. Okay, so both gets calculated. Now what I do, this uh, the second function I write, I have to flip it, right? Because internally it has to be flipped. So let's do that. So h is equal to, I'll try to make a rotation. If you remember, there is a function called ROT90, right? It rotates by 90 degree of, right? This is the h. So twice it rotates. You know that this is a flipping operation, correct? For a matrix. Right, let's do that. Then let me define where is the center element. I have to identify where is the top and where is the right, left, bottom, etc. I have to find out all those positions, right? So that's what is my basic idea now. So let me start with that. So that is H. I created the H. Now I define where is the center. Center of my resultant is nothing but floor of, I'll make a floor, why you understand now. So I'll take the size of this h. Okay, size of h, right, plus 1, and I divide this by 2. So for that reason I'll add another bracket. So divide this by 2. So that's where the center is identified. You can verify our previous problems to identify where is the center of your result, right? So whatever is the second function, take plus 1 to that size divided by 2. Okay, then I'll find out where is the what you call the leftmost position. Okay, so left, okay, I'll call this is left is equal to, let me do one thing. I already have calculated center, right? It's actually 1 less than the center. So I can write it as center of the second minus 1. Then we have the right value. So this is nothing but the total n, right? N you can find because that's the size of your, what you call, the H matrix, right? That is n. You should subtract the center from that. So you get the rightmost position. Then the top position. Now, how to obtain the top? It is located in the center's first position. So center of 1, okay, minus 1. Then I need to find out the bottom. That is equal to m minus the center of 1. All right. So now you identified where are the top, left, right, etc. Okay, for this. Now I put the results here. So I can put that over there. So this is how, let's start with this. So create the zeros. Okay, so I'll call this is equal to, put zeros of, what is the size? So size should be equal to the number of rows in the first matrix, that is R, right? To that you add the top and bottom plus, so this you add top and bottom, comma. I need a sufficiently large number of columns as well, so that will be C, right, plus left and the right. So many zeros are now. So this means I can start with the making the values. I copy, right? Because whatever is your first function needs to be copied, right? In within the zeros. At the center of these zeros, you have performed the zero padding, and it has to come, right? So the values of A should come. Sorry, values of your first matrix should come in the middle. So I'm trying to do that. Okay, so let me start with the for loop. So for the I is equal to, I should start from 1 plus top, right? Because it's not the starting position, it's 1 plus top, from there which it should start. Okay, so 1 plus top, starting from there it has to go till where, till 1 plus top to R plus top. Okay, R plus top, till there you have to, I will change from there. At the same time you can see that I have to change my J as well. So one more loop. For J is equal to, now you see it is 1 plus left to C plus left. 1 plus left till, I think C was the columns. Yes, C plus left. So until and unless this is done, right, you replicate your value. So REP I comma J is equal to, from where you copy from the matrix, that is X matrix. Okay, so this is X of, it's simply X of, what I should write, uh, the coordinate of this I minus the top value. Okay, I minus top, comma, what should be the Y value? It is J minus the left. Okay, from the top, so many positions to the downwards, and from J it is left. Okay, J minus. So keep repeating this so that you finish the zero padding. Zero padding is over. Now first matrix is inside the REP. Okay, so instead of REP you can call it zero padded. Okay, ZPD matrix. Okay, right. So I'll just write, maybe instead of giving this name I can write, so this is ZPD, right? So zero padding. Okay, now I create the answer. Answer is Y. So Y is equal to, I'm expecting the size same as that of your matrix, right? So size of Y should be same as the size of X, correct? So this should have zeros. How many zeros? R comma C, rows and columns. So many, what you call, zeros have been created. Now you see, right? Let's just start with the for. So this is the convolution part. For I is equal to 1 till, I have to consider my first matrix. So first matrix row wise will be 1 to R. Go with the second one. For J is equal to, it's the column of the same matrix, right? So J is equal to 1 to where? Till C. Okay, Now this is for the first matrix. This should be, I need to consider the second matrix as well. In the second matrix, first row and first column, first row second, first row third, and so on, for which I need another one. So for k is equal to 1, 2, till where? Till the m, 1 to m. And similarly perform this for L is equal to 1 till n. So 4 for loops now. Okay, right. Now you look at what you are going to do. I have to find out the one value lesser than my uh, whatever position it is. So that I'll denote it to A. Okay, so A is equal to, always start with one less than one because there are zeros added now. So this is I minus 1, and B is equal to 1 less than your the second index, that is J. So this is J minus 1 to the calculation. So result is nothing but the Y. So Y of I comma J is equal to, you already initialize that. So to that number you keep adding. So this is Y of I comma J to this add plus whatever was the zero padded one, right? I have to multiply. Okay, so that is, I think the name is ZPD, the zero padded matrix. In that, do the I plus A, comma, the J should be added with the second one. So J plus B, right? This is getting multiplied with which one? The second one. Second one is simply H of I comma J, right? I comma J into I comma J is what you are doing, right? So do this, right? And, 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 and. So you finish this. Now you see the Y will be returned ultimately. Once this is done, the Y will go back as an answer. Okay, so this is the function. All right, let's check the function first. All right. So, right. So I will directly pass the two values which we have actually calculated just now. All right. So that we can make sure that our answer is correct. Okay. So x is equal to, let's write 1 minus 3, 4 minus 5, 6, 2, 0, 0, 3 minus 1, 2, 0, 0, 3 minus 1, minus 1, 1, 0, minus 1, 1, 1, 1, 2, minus 3, minus 1, 1, minus 1, 2, 3. Okay, so this is the first matrix. Then we'll write the second matrix. H is equal to 1, 2, 1, 2, minus 1, 2, minus 1, 2, plus 1. All right, so I'll call the function now. So y is equal to, this is convolution, two dimensions of the first function h and the second function h. Let's see. All right, there is some issue with the function. Let's just check. Okay, okay, RHHT. Sorry, there's a spelling mistake. I think. Well, I expect the comma here. Okay, that's why it is shown. Let's see. It says line number 23, index position 2, index position 2 exceeds array bounds. Okay, let's just verify. Let me just verify the code once. X really so I is 1 to R, 1 to C, okay, that's a mistake here. So this is actually, we are not using the K anywhere. That's a mistake. So this is K. This is L. Okay, so this also should be K and L. It's obvious because we have to use the second function, right? So because of that, let me just verify once again. J, y of ij plus the zero padded matrix. So this is K plus A. Okay, and plus B. Okay, this looks like. All right, let's just check whether this is going to. Okay, so we got a 5 into 5. So you can just verify the answer you got with this. So minus 3. After that we have minus. Okay, calculate the second position. You told 11. It says 15. Kindly verify once. Okay, I can actually verify another method here by using a built-in function. So first let's verify whether our code is correct. Okay, don't compare with your answer. I suggest that we need to verify with the function itself. All right. So let's try to do one thing here. That is, we'll multiply. Sorry, we'll do the convolution directly with the built-in. Okay. So this is, let me call this is say y2. Another answer. All right. So this is y2 is equal to, there's a built-in function that is called as conv2. It's a two-dimensional convolution of, right, uh, what you want to convert, you just have to mention. So it's x comma h. All right, x is my first sequence, x, but you need to specify x, and after x, you need to say that what is the expected output, because there is no separate function for zero padding here. If you want the result to be the same size as that of x, you need to specify same over here. Okay, otherwise, what it does, I'll show you later. Okay, so let's just, so now you can see, right? So compare y and y2. I'll just make it bigger so that we can understand the code what we have written is correct or not, right? So this result is because of the code which we have written, and this is the code, right, that MATLAB does by using its inbuilt function. I think both are same, right? Yes. So now you compare this results with the one answer which you had given earlier, right? So I think there is one or two points which are missing. Okay, I'll slightly, I'd like to highlight that. Okay, so I want you to verify once. So one is this, then minus 17 we have, then it says 24. There's a small thing. Okay, and minus 15. So there is a difference over here. 2 minus 4, 20 minus 12. So these values, 10, 3 minus 10, 4, 4. Okay, 10 is right. So these four are different than what we have. 6, 7, 16. These are also different. There's 4 minus 3, 8, 10, and minus 3. Okay, so anyway, take your time. Just make sure that you understand how to do it manually. Anyway, once we write the code, we never use the manual calculation, but it is suggested that you know, right, how to do it manually when required. Okay, so moving ahead, what happens if I don't specify same? I'll show you. Okay, so my intention is to use an inbuilt function, but not to use the word same. I'll simply do this. Now you see, actually, right, you got a bigger answer. It it puts a lot of zeros. There is a lot of zero padding that is happening, right? And right, you get an answer. Okay, so that's the result of not mentioning same. So what are the other options you have, right, that you can mention over there, right? One is, this is called as a full. When you don't say full, right, the default option is this. This is something like you are writing like uh, h comma, you are writing a full, right? This is same as what we got, right? It's the same thing. It's a default value is full. The optimum answer is called as, right, substituting a what do you call, same over there. What's the other option? The other option is called as valid, right? So this is what's going to happen when you don't uh, do the zero padding. Without zero padding, simply, right, do the convolution. I'm getting a smaller answer. So the smaller answer is, right. Yeah, sorry for that. I'll repeat what I do. Right, I think the screen was not visible. Right, I'll repeat. Okay, so now, okay, till here, I think you are fine, right? So, right, we calculated using our function and the built-in function conv2, right? Now, conv2 used a keyword called same, right? Same indicates that I want the mat resulting, the size of the answer of the convolution to be same as that of your first variable, that is x, right? It was a 5 into 5. It added so many number of zeros that it match, the answer matches to the size. There is another thing that is called as a full, right? Full indicates a default. Even if you don't mention the full over here, it still works. So you can see the answer here. It actually adds much more number of zeros than required. So you can see that the result is much bigger. It's a full convolution, right? It's not that you add only one row, one column. You can add two rows, two columns as well, right? Three rows, three columns of zeros as well can be added, correct? So it performs that and it shows you all the answers without any where you don't get zeros. Okay, only those answers are shown. And other one is a valid. Valid indicates no zero padding. Perform the convolution as it is. So when this convolution happens, you see the result has a lesser size than your original function. Okay, so these are the three options. I also so far what we did today is we did a manual calculation, then we wrote a code, right? And we wrote our own function, right, to implement this, right? So go through this. I'll share you this code. Go through the code and understand. Okay, if you have doubt, I can explain, right? Also, we know now there is a inbuilt command called conv2. It has varieties of options because you don't have to write different commands for zero padding, without zero padding, etc. You just can call zero padding if you want. If you don't want a zero padding, simply call it as a value. Okay, you want zero padding and optimum values, then call it as same, right? And you are not worried about what you're going to get. You simply want to do a convolution with as many with a bigger answer, as many zeros as possible you want to pad. Then that will be simply calling x comma h with the full option or not writing, because full is a default in this case. Okay, so these are the options available to perform the 2D circular convolution, 2D convolution, not circular, sorry, 2D convolution in the MATLAB.